In this question, we are given with fourth, seventh, and last term of GPR 1080 and 2560. We need to find the first term and number of terms in this GP. So we are given with A4 equals 10. That means A r to the power 3 is equal to 10. A7 is given as 80. That means A r to the power 6 is equal to 80. And the last term, which is an, is given as 2560. So we have a r to the power n minus 1 is equal to 2560. We can name these equations as 1, 2, and 3. And we want to find the value of a as well as the value of n. If you divide equation 1 and 2, a will cancel out and you will have something entirely in terms of r. So we can find r from there. So let's divide equation 2 by equation 1, which will give us a r to the power 6 divided by a r to the power 3 is equal to 80 over 10. And here we can cancel out a, we can cancel out r cube. So you have r cube equals 8. R cube equals 8 means r should be equal to 2. So now we know the value of r is equal to 2. If we use this value of r in equation 1 or equation 2, we will get the value of a. If we use r equals 2 in equation 1, we get a times 2 cube is equal to 10. That means a is equal to 10 over 8 or 5 over 4. So we get the value of a as 5 over 4. Now we need to find the value of n. We know the value of a is 5 over 4. We know the value of r is equal to 2. We can substitute these two values in equation 3. So using a equals 5 over 4 and r equals 2 in equation 3, we have 5 over 4 times r, which is 2 raised to the power n minus 1 is equal to 2560. We can simplify this further by 2 raised to the power n minus 1 is equal to 2560 times 4 over 5. So you're dividing both sides by 5 over 4. The left hand side is 2 raised to the power n minus 1. And on the right hand side, we can cancel out 5 and 2560, which will give you 512. And if we factorize the right hand side, we will get the right hand side equals 2 raised to the power 11. Now here the bases are equal, therefore the powers should be equal. That means n minus 1 should be equal to 11 or n is equal to 12. And that gives you the number of terms in the sequence is 12.